Perfect. So
Great.
Melissa is the only North American certified component certifier. Is that, did I say it right?
Yeah, I think they call it component assessor is the phrase that they use, but
There
yeah.
you go. So I'm excited to introduce her, and her experience will help us all. Thank you.
Yeah, thank you. Yeah, so today I thought I would talk about some key learnings that I found through working with different manufacturers as a passive house component assessor. My name is Melissa Furukawa. I am a certified passive house consultant, component assessor, building certifier, trader. I did put that on, and I work for a company called Peel Passive House Consulting. Um, so actually, I'm based in Canada. Um, I work for a company called Peel Passive House Consulting. If any of you know Andrew Peel, he's the founder, and we do passive house consultancy work. We also do passive house building certification. So that's us acting as the third party verifier to make sure all the building is meeting all of the passive house requirements. We also do component certification, and for this, we work very closely with the Passive House Institute. Yeah, kind of again working with manufacturers. We do all the modeling, submit all the documentation to PHI. In the end, both for building certification and component certification, PHI gives the certificate, but we're kind of acting as the reviewer on their behalf. We also do some passive house research. Right now, we're doing a research project on supply air cooling to see if we can provide all the cooling for the building through just the supply air. And in this kind of way, we can have one heat pump to provide domestic hot water, heating, and cooling. No extra ductwork for any of the HVAC stuff. Yeah, so that's underway. We have some pilot projects going up all over Canada. And we also do passive house training. So if you are already a CPHD and you need those credit points to keep your designation, we have some master classes on our website. They're all self-paced, so you can do them on your own time. We have a design PH course, a third course, Heat 3, which is for 3D modeling. Yeah, can't think of the other ones, but we have a whole bunch of different courses for those folks who kind of already have their designation. Okay, so yeah, today I'm going to be talking a lot about Windows. So first of all, like why should we certify our Windows? We're just seeing a huge boom in high performance buildings, and as we all know, high performance buildings require high performance components. So this is, you know, the ventilation system, the HVAC system, but also the windows and the doors, the air barrier materials. So as we have this rise in high performance buildings, we also see this rise in demand for passive house certified components. And why passive house in specific is because that certification provides assurance that the products are complying with a rigorous standard for quality and performance. And you know, if you've ever worked on a passive house project, we need, in order to do that PHP modeling, we need certain performance values that aren't always easy to get if without that certification. So by going through the certification, you have all of the information that the consultant would need in order to model the building with those windows. And this just facilitates an easy and streamlined process to assess different components to see, okay, like, does this work? Like you can kind of test different window options and see what works for your building because passive house is a holistic approach. So it's not like, you know, you have to have this R value or you have to use this, you know, efficiency ventilation unit. It takes in consideration the whole building and all these different moving parts. So we want to be able to have an easy way to test different options. So now I'm just going to kind of go over the criteria for Passive House certification. So if I click this, then I have to switch my screen here. Oh yes, by the way, if you have any questions during the presentation, please feel free to just unmute yourself. I'll try to, I don't think I have the chat open, but maybe somebody can like let me know if there's a question in the chat. I'm happy to just answer questions as we're going. I feel like sometimes that's
Yes, I'll keep
easier.
a track of the questions, and as
Okay,
they come,
great.
I will let you know.
Yeah, thanks. Thanks, Hima. Yeah, sometimes that's just easier than trying to remember your question and then go back to it at the end. So this is just the criteria, which is available on the Passive House Institute website. I'm not going to go over it, but just kind of an overview. It kind of goes over all the different criteria for the different climate zones. It also goes over kind of what kind of modeling is required for different window types. So you have like window frames, but you also have doors and sliding doors and curtain walls and skylights. And so there's many different, yeah, there's some kind of nuances between those. Yeah, and then it just kind of goes over all of the requirements and kind of a description of them and how to calculate things. Yeah, so that's available if you want to kind of take a deeper dive into that. But fundamentally, the criteria is looking at 4 different things. One is hygiene, the second one is comfort. Then we also have energy and airtightness. And these are the kind of yeah, fundamental criteria. So hygiene, when we're looking at hygiene, we're really trying to reduce the risk or mitigate the risk of condensation and mold. And the way that we do that is ensuring that we have that minimum temperature on the interior surface of the window is high enough, basically, so that we don't have condensation forming and that we don't have this risk of mold growth. And this includes on the frame, but also on the glazing and also on the glazing edge where the glass meets the frame. And this is actually where we typically see the lowest temperature on the inside of the window, and it's because of the thermal bridge created by the spacer, which we'll talk about more. Comfort. So what are the main benefits of Passive House? I mean, first, I think everybody always thinks energy, but second is comfort. So we want the occupants to be comfortable in the home, even if they're sitting right next to the window on the coldest day of the year, they should feel comfortable. So the way that we ensure this is that the average surface temperature on the entire window is high enough. And, you know, in traditional like code buildings, a lot of the times to reduce well, condensation risk and mold growth and to improve the comfort is there's a heater near the window. So this is, you know, an unnecessary added component, an added expense, an added like design, you know, it impacts the design and the functionality of the space. But with Passive House, we don't need that. And we, you know, it's been shown that we can achieve both comfort and hygiene without having these additional heaters. Obviously, if we're talking about Passive House, we're thinking about energy and the thermal performance. So the whole window has to meet a certain U value. So there's kind of a maximum U value or a minimum R value that the whole window has to meet. And this is basically to ensure that we're not losing heat over the winter, and we're reducing the total energy demand of the building. And the last thing is airtightness. So yeah, that we want the window to be airtight to avoid drafts, cold spots, condensation and mold growth, and also high energy demand. So this aspect really supports all of the other 3 criteria. And just like, you know, we have a whole building airtightness requirement. So obviously like the whole building needs to have an air barrier and be connected, but you know, the windows are a key part that if the window is leaky, then the whole building is going to be leaky. And especially like for operable windows, the way to kind of ensure this is by having a triple gasketed, which we'll talk about. Yeah, so the criteria is really based on the climate zone. So for Passive House, they have kind of their own system of climate zones. You can see it in this map here. In New York, we're in this kind of darker blue area, which is cool temperate. So just kind of keep that in mind. So this is the criteria for the Passive House window certification for cool temperate. So the criteria is in metric units. So I've also put it in just for cool temperate. I put it in imperial units down here. The first kind of point is the hygiene criteria, which I'll explain what that is. But basically, you have to be the hygiene, the FRSI has to be greater than 0.7. It's a unitless number, so it's the same in metric and imperial. The whole window U value, so that includes the glazing, the frame, the psi value of the spacer has to be at least, less than 0.8. Or less than 0.14 in metric units, imperial units. Then you also have to show that the window can be installed in 3 different wall types with minimal thermal bridging. So that U value of the window, including the psi value of the installs, has to be less than 0.85 or 0.15 in imperial. And then this last part is just the reference glazing that you have to use. So depending on the climate zone, you have to use a certain reference glazing. Okay, so what is this FRSI? This is really pointing to that minimum temperature, and it's a way to kind of it's a metric, I guess, to determine if there's going to be a risk of condensation or mold growth. So the calculation is basically you do a thermal model and you kind of see where's that minimum temperature on the interior surface. And the equation is basically the minimum interior surface temperature minus the outside temperature divided by the inside temperature minus the outside temperature. So for this example, the minimum interior surface temperature is 11.6. This is all in Celsius. You kind of have to do it it doesn't kind of work if you do it in Fahrenheit because the temperature differences are not the same. But yeah, it's 11.6 degrees Celsius here, and then you minus the minus 10 as the outside. Typically, you model it as minus 10 on the outside and 20 degrees on the inside. So if you do that math, then you get 0.72 for this window. And if you remember, the criteria is 0.7, so we've met that criteria. It's greater than 0.7. The next metric is the component U value. So this is the equation. Basically, it calculates the whole U value of the entire window by multiplying the area of the glazing multiplied by the U value of the glazing plus the area of the frame times the U value of the frame plus the length of the glazing, the glazing edge. So that's kind of around the perimeter of the glass, multiplied by the psi value of this glazing edge or spacer, and then all divided by the total area of the window, which is the area of the glazing plus the area of the frame. So this all together, you can calculate the whole U value of the window, and that has to meet a certain criteria. And then like I said before, you also have to show that it can be installed in 3 different wall types. So basically, to get the U value of the installed window, you just add the length of the install. So that's just the perimeter of the whole window multiplied by the psi value of the install. Okay, so yeah, over the years, I've been kind of working on a lot of different, with a lot of different manufacturers on a lot of different window types. Mainly aiming for either cool temperate or cold or cold climate certification. So these are just some tips that I've kind of picked up over the years. Yeah, just kind of working through some things. So the first one is that the Passive House certification is really testing the frame and not the whole window package. So for cool temperate, for example, you have to use a reference glazing of U value 0.7. The manufacturer may have glazing packages available that are less than that. And like 0.7 is, I would say, like fairly high. Like for a triple pane, Bowie coating glass, you can definitely get down to like 0.55, 0.6. So they may have glazing packages that are, even lower than this, but for certification, you have to use whatever the reference glazing is for the climate zone that you want to certify for. Mhm. Okay, so where to insulate? Get rid of this. Okay. Yeah, so looking at like PVC or fiberglass windows, it's most effective to insulate the larger air cavities that align with the glazing. So these smaller cavities over here, well, first of all, it'll be so difficult to insulate, and second of all, it has not a very big impact. For operable windows, it's important to break up this air gap that is between the sash and the frame, so that you can break it up with gaskets or just basically because the bigger this air gap is, so air gaps do have conductivity, and they do have kind of insulative values, and the smaller the air gaps, the lower the conductivity is. So if you have a big air gap, then it's going to have a high conductivity and kind of increase the overall U value of the frame. Like I said before, for air tightness purposes and water tightness purposes, it's important that operable frames be triple gasketed in order to meet those requirements. So this one has 3 gaskets in between the frame and the sash. And yeah, these gaskets also are helping to break up this air cavity here. Okay. Yeah, talking about the air cavities again, we were recently working with a PVC, a window manufacturer for PVC with a PVC frame. And actually, I was kind of surprised that they were able to certify their PVC frame with no insulation. And it's because the frame, like to make up the kind of design of the frame, there's all these like small air cavities. And so those small air cavities, because they have small dimensions, they have enough thermal resistance without any insulation to meet the cool temperate passivhaus requirements. Yeah, so this company, that's kind of their whole thing. Like they don't want to use foam, and so they've kind of designed a product that doesn't require any foam in it. Okay, I talked a little bit about this size spacer or glazing edge, but basically the spacers that you put in between, so this is the glass, and then we have like either air gap or gas filled gaps in here, and these spacers kind of keep the glass in place. And yeah, there's various ways to kind of reduce the psi value of that spacer. One is to obviously use like a high performance spacer, and there are many kind of available. And the other one is to also inset the glazing deeper into the frame. So you can see like this depth here, it's kind of deeper into the frame than like, well, this one's not too bad, but like this one. So you can kind of play with like how deep is that glazing inserted into the frame. And this can both reduce the psi value of the spacer, but also reduce the internal that minimum temperature on the inside, which therefore improves the FRSI value. Another way to improve that psi value of the spacer is to add like a backer rod or some other material between the glazing stops. This just provides a kind of extra buffer and also breaks up this air gap underneath between the glazing and the frame. Yeah, there's been a lot of interest in manufacturers, I guess, especially in Canada, wanting to have a cold climate frame. And oops, I think can you still hear me?
Yeah.
I think, oh,
Yes.
okay. There was a sound and I wasn't sure mm, if my headset like turned off, but okay. Um, yeah, so there's been a lot of interest in getting cold climate certified. And there's not a ton of cold climate certified windows available on the database. And for good reason. It's a hard target to meet. It's very demanding. A lot of the windows, if you look on the database, a lot of the windows are timber windows that have exterior insulation. And the reason for that, like, what I found from working with manufacturers, is if you have like a fiberglass frame or a PVC frame, it's just really hard to meet without using some kind of like very high performance insulation like aerogel. So aerogel is an insulation product that has a very low conductivity, like 0.014. That's in metric units, but um, yeah, just like a very low. And it was originally developed like for space use or something. So it's also very expensive. But yeah, it can be very challenging to meet the criteria for cold climate without these kind of really high performance insulation products. And then we also had I've been working recently with an aluminum frame window manufacturer. And yeah, this was an interesting project where they had different frames sizes. So they had like a small frame and a small sash, and like a small frame and a large sash, and a large frame and a small sash, and then like a large frame, large sash. Anyways, so we did kind of these variant modelings to see, okay, what is the impact? And I was kind of surprised to see that actually a larger frame could be beneficial, because like here's an example here. This larger frame has so we have aluminum frame, that's the gray, and then this kind of red piece is the thermal break between the aluminum frame, and then this kind of darker yellow and lighter yellow is the insulation. So if you have a kind of larger frame, then it allows for more continuous insulation. But like if you think back to the formula, when you're calculating the overall U value of the frame, there's the glazing and there's the frame. But you're calculating it for a fixed window size. So the bigger your frame is, it just means there's going to be a larger proportion of frame than glazing. And typically the glazing has a much lower U value than the frame. So it's kind of counterintuitive. Like usually you want to have less frame because it's a higher U value. But in this scenario, because by increasing the frame, we can add more insulation and therefore reduce the U value. It actually was beneficial overall. So yeah, sometimes like you don't really like you think one thing, but you know you really have to do the testing to see and the calculation to see. Yeah. And then, yeah, this is talking more about aluminum clad windows. Sometimes you have PVC windows with aluminum cladding. Sometimes it's only on the outside. But in this case, it's on the inside and the outside. This is a warm temperate window that I just pulled from the database. But as an example, they have aluminum on the outside and all of the inside. And this part here, like really like clips into the frame. And you can see it in this isotherm. So the isotherm is lines of constant temperature. So you can see that it really like there's a huge thermal bridge here, which you can tell by the lines, the isotherm lines, and it's really creating a thermal bridge by like this. I mean, there's still a gap obviously between these pieces. They're not like directly connected, but the more that this aluminum kind of goes into the frame, the more it's going to impact the overall U value of the frame. So like if it was just on the outside, like that would probably, like if they didn't have aluminum on the inside, that would probably greatly improve the performance of um the overall U value of the window frame. Yeah, recently we were working with the manufacturer on, I think it was a door, and they had both aluminum on the inside and the outside, and this was a kind of similar issue where it kind of clipped into the frame. such that it was having a big impact on the performance. And even this little bit, like even if this, I did a test, like if this little bit was PVC instead, or if it didn't go in as much, like it can make a huge difference because aluminum is so conductive. Yeah, so that's all that I have for you today. Thank you very much. If you have any questions, happy to answer them.
So thank you so much. There is one question from William. William, would you like to ask the question?
Oh, yeah. Hi, Melissa. Thank you. That was really interesting. I just was wondering if there were any new materials that are being considered for manufacturing window frames. We've had
Oh, yeah.
fiberglass for quite a while now. That was the latest new thing, like
Yeah.
15. All right.
Yeah, I guess the main ones are fiberglass, PVC, aluminum, and also wood, which I haven't had the chance to like do a wood window, like in terms of like certifying it, but or assessing it, but I've seen them in person, and I love the aesthetics of just like a solid, like it's just a solid wood window, and I think it just looks like so warm and beautiful on the inside. Yeah, but I haven't, yeah, in terms of like new materials, I haven't heard of any like, yeah, new.
Yeah, I was wondering, more
materials.
more organic, more insulated or something. Okay, thank you.
Oh, there's a retrofit project.
Yes, so I have had this question because
Oh, yeah.
like I work with a lot of NYCHA projects. So there the building is very big, like it's 14 stories and there are a lot of windows. And because it is financed, sometimes they want to change the windows, but they are not doing proper insulation in the walls. So then how much does it make sense? Like if just a new window will be good, or still we can invest in a triple pane window?
Yeah, that's hard to say. I think it depends on like what is the existing condition in the wall. Like, is there any?
There is no
There's
insulation.
no insulation. Then
Yeah.
yeah, it's hard. Then it's hard to like, well, yeah, because heat will always like move through the like it'll always find the easiest pathway through. Like you can do a model and kind of see the impact, but I would probably say it's not worth like putting it up. It's probably worth replacing the windows and making sure they're airtight and making sure, water is, being taken care of, and as thermal free as you can. I don't know if it makes sense to go to like triple pane and like a passive house window,
Okay.
but maybe like higher performance than
Will then be better.
was existing. Yeah. Yeah.
That
Are
makes
there,
sense. Thank you.
can I just follow up on that? Are there ways of preparing the window, the rough window opening when you take out the old window, right? And this is a retrofit like you're talking about right now, to prepare the opening, to make some thermal, to limit thermal bridging.
Yeah. Sorry. Is what your question is there a way to prepare the
To prepare window
Yeah.
openings in a retrofit like you're talking about, like a NYCHA building. They took out the old window. Can we do something with the rough opening before we put the new window in to help?
Yeah. Yeah, for sure. And you can, well, yeah, it's kind of hard. Typically, for passive house, you want to align the window in the insulation layer. So if there's no insulation layer, then you don't really have to worry about that. But yeah, like air sealing and making sure like you're taking care of the window with the of the water, if there's any water that gets through. So like having proper flashing. Yeah.
Next question is from James. James? Okay, you can unmute yourself and ask the question. Or I will ask the question
Well, I
for
can read it. So it says, could you offer tips for wood frame windows and doors? As mentioned in the breakout, this is what I currently manufacture here in New York City. Can you talk about any advantages or performance characteristics of wood versus other materials?
Sorry about that. I was trying to get my mic hooked up.
Oh, no
Next.
problem.
Yep.
Yeah, I haven't had, yeah, if you want to certify your windows, let me know because I haven't got a chance to work on a wood window yet. But like I
Yep.
said, I think like aesthetically, I think it's beautiful, and like from a low carbon footprint, I think it's a great option.
Yeah, absolutely.
Yeah, I don't know if there's any like thing specific for wood. I guess like um if you want to kind of reach higher performance, I've seen them do like wood and then have a layer of exterior insulation on the outside and then like clad with aluminum or something like that.
I did
Um,
see, yeah, I did hear you mention that. And that was one
yeah,
of
so
my
that's a way
maybe
to kind
later
of
questions
boost.
down here. Mhm.
Yeah, that's a kind of way to boost the thermal performance to reach like cold climate. And I've seen in the database like windows, yeah, just kind of using regular, I mean it's foam, but insulation products to
Mhm.
achieve that.
Yeah, I have a few like tests and experiments going with that and doing some, research internally in the shop.
Mm.
But was just curious if you, yeah, or if you had any insider information about like advantages of the, thermal performance characteristics of wood versus some of the other materials mentioned, because, it does have that R value to it. You are
Mhm.
laying up multiple, you're not using one solid piece, you're laying up multiple layers to create the depth and strength for the profile.
Mhm.
And potentially could be incorporating other layers in that.
Yeah, so I think like wood definitely has like a lower conductivity than other like fiberglass or PVC. So I think that's um one of the reasons why it's kind of easy or um
Yeah.
like you see like I've seen it like there's quite a few wood windows in the like certified wood windows. So I think that's why it's a kind of popular choice. Um
Yeah,
yeah.
so to go for because I've done like, ISO 177-2 modeling, but
Mm,
I don't have like a certification through Passive House Institute.
mm.
Um, and just yeah, I was curious. So like we know it's possible, right? And
Yeah.
and should be hopefully encouraged over
Are you seeing a lot of
non-recyclable
people?
materials like PVC
Yeah.
or
Yeah. Are you having a lot of clients like asking you for certification or
no, no one's really asking for
mm,
that yet. The projects I've worked on, I can hit the marks, but the total project isn't going for certification anyway.
mm,
Typically that's actually fairly rare. Though they might build to the standards and still hit all the
yeah,
blower door
yeah,
tests and build it correctly,
yeah.
that it could get certified. Most of them,
Hmm.
actually don't go for certification,
Mm,
I guess just because of
mm.
the additional process to it. But yeah, so I haven't been asked about that, but I felt like being, certified in a database system, just as you're suggesting, the power of maybe being certified could um, put me in the system
Yeah,
along with
because
being
I
a
mean,
certified tradesperson.
yeah, when we're working, sorry, my headphones still hear me. But when we're working like as a consultant on a project, like often clients are asking us like what windows should we use, and then we kind of know like what's available and then in the locally and like in the region. And yeah, a lot of times I think people look at the database to say what's available. So it does like maybe you're not getting on the passive house projects. I don't know. It's kind of like what comes first, right? The chicken or the egg. And
Yeah, for me, I'm a small one-man operation. It's a small business, and I build the projects as they come in as I can get them. So
yeah,
certification hasn't been number one
yeah,
priority,
yeah.
as it hasn't been number one priority for the clients so far. But
Mhm.
I see, sort of the advantage of being in that system to be able to be found more readily rather
Yeah.
than having to
Yeah.
do all the work myself. I of course
Mhm.
enjoy working in a pretty close-knit community here in New York, but I don't know everyone and everyone doesn't know me. It takes a lot of time to put that
Mhm.
effort out.
Mhm. Mhm.
Just a thought.
Yeah, well, if you ever are interested in pursuing it, yeah, please reach out to me.
And
Yeah.
has Peel Passive done a wood window frame, or it's just that you personally have not reviewed one?
Like we haven't, because I'm the one
Oh,
doing it. Yeah.
oh,
Yeah, we just haven't had that. We just haven't had the opportunity. Yeah,
okay. Maybe we should connect.
so that'll be fun.
Okay, thanks.
Is the next one Andrew? Are you seeing more certified storefronts? I think a few years ago there was one manufacturer based in central Canada that had a product, but it was rather limited. Yeah, I think we're definitely seeing like more and more like curtain wall windows and for commercial buildings, because passive now, I mean, passive house is way more than just homes, right? And some people kind of focus on homes and houses, but we've worked on, there's office buildings, there's multifamily buildings that sometimes have, a ground floor that has commercial use. We also worked on the first Subaru car dealership. So there's a lot of different, more commercial windows that are being required on these passive house buildings and being specified. And yeah, so the demand is definitely increasing for that. And the products are, I can't think of it off the top of my head, but there's definitely products available. Um, The next question is from Steven. Does your modeling of the windows include NFR and FRC whole window U values and solar heat gain coefficient results? No. So so one of the issues with kind of modeling windows in PHPP is that we need like all these different components, right? Like we need the U value of the frame, we need the U value of the glazing like separately, and also the psi value of the spacer. And that's often like what you have is the NFRC whole window U value, but you can't really input that into PHP. And so that's why the certification is valuable for passive house projects. So it does calculate a whole window U value, but I'm not sure exactly. The whole window U value depends on like dimensions of the window, what U value you're using for the glazing. So there may be it might not be like a direct match. I'm not really sure exactly what the kind of calculation procedure is for NFRC. And we don't calculate the solar heat gain. Like I mentioned before, you have to use a kind of reference glazing with a certain U value. So it's not actually considering like what is the glazing package available from the manufacturer. But typically, like when you do like purchase a window and specify it, like you would just ask the manufacturer, like, and they have many different glazing packages available to have, all these different combinations of solar heat gain coefficient and different U values. And it's good to test, like sometimes we will specify a certain glazing for the south and a different one for the north. And so it's good to like kind of test, like sometimes usually the lower the U value, the lower the solar heat gain coefficient, but sometimes it's beneficial to have a slightly higher U value if it means more solar heat gain. Another question was, one tip mentioned for improving performance was adding a bracket rod at the glass edge between the stops. Does structural glazing work here as well, or even better? What do you mean by structural? I'm not familiar with that term.
So sometimes there's dry gaskets around the glass, between the stop to the glass. Other times like a wet glazing, like a structural glazing, will be used.
Mhm.
Partly to rigidize the frame and for other purposes.
So that
Um,
means that the glazing is kind of sitting right on the frame?
No, it has a space to between the glass and the stop.
Mhm.
And we use glazing spacers in the space between the glass edge and the wood frame, of course, but between that, stitched between that in those little air pockets, you could simply run a bead of caulk. Let's just say caulk in general, if you're not familiar with structural glazing. Does caulk work equivalently to?
Mhm. Yeah,
Um,
I mean, it's really anything to kind of break up that air gap that's below the glazing, and this helps again to like improve that the side value of the glazing edge. And I guess it depends on like what the materials and what the conductivity is. But yeah, generally it is helpful to have something to kind of break up that air gap.
yeah, I use it just to, stitch the glass even stronger to the frame because it dries hard and gives it that like rigidity
Yeah.
on big frames. But
Yeah.
I was,
And it
as you
probably
mentioned
helps
it,
with like the air tightness and yeah.
that's what I was thinking. As you mentioned that maybe it would be better than backer rod.
Mm-hmm. Mm-hmm.
Okay, thanks.